Hello, this is Mrs. Ward, and I am doing the semester review. This video is going to cover the free response section of the exam. So just to remind you, you are going to get this blank unit circle. You are going to get this identity sheet exactly the way you see it here. So whatever is filled in is what you will get filled in. Whatever is not filled in, you will not get filled in. We don't give you this. We're just asking you to write this down to help you study. And you do get this table blank. Remember, we filled it in when we did the graphing part, but you will get that table blank, and then you can fill it in depending on when you need to fill it in. All right, so let's do free response. So we're going to skip, we did the graphing already. Okay, so the first one that is not graphing is number 9. It says evaluate the identify the trigonomic functions without a calculator. So this is asking you to look on your unit circle, and it's asking you when is the tangent of x equal to the square root of 3. Because it's using this inverse notation, remember the tangent can only come from the first and the fourth quadrant. This happens to be positive, so it's going to come from the first quadrant. And so I'm going to say that theta is equal to pi over 3, because that's when the tangent is equal to square root of 3. The next one is asking arc cosine of a negative square root of 2 over 2. Arc cosine is the same thing as the inverse cosine. Remember, cosine, the inverse cosine is defined in the first or the second quadrant. Since this is negative, I'm going to pull my angle from the second quadrant, and the cosine is equal to the square root of 2 over 2 at 3 pi over 4. The last one is the inverse sine. Again, the inverse sine is defined in the first and the fourth quadrant. It's the same as the tangent. I'm asking myself, when is the sine equal to 1/2? And that answer is going to be pi over 6. Remember, there are two places on the unit circle where the sine is equal to 1/2, but if it's written in the arc sine or the inverse sine, you can only give the answer from the first quadrant. Okay, the number 10 is simplifying the expression. So I look at secant squared and minus 1. And I might want to change it into Pythagorean identity, but I see that the denominator is also secant x minus 1. So what I'm going to do is I'm going to factor the numerator as a difference of two perfect squares. So secant x plus 1, secant x minus 1, and that's all over secant x minus 1. Now that I have these two being multiplied, I can simplify those, and I'm going to be left with secant x plus 1. Moving on to the next one, I have cosecant squared x times 1 minus cosine squared x. So this, I'm going to use a Pythagorean identity and write that as sine squared x, and that's going to be multiplied by cosecant squared x. I'm probably going to change the cosecant to 1 over sine squared and leave the sine squared as sine squared, but I might want to write that over 1 so I can see what I'm doing. And then the sine squareds will simplify, and I'm just left with 1. Moving on to the next one, it's asking me to solve the equation in the interval from 0 to 2 pi. So I am going to bring everything to the one side, bring everything to the one side of the equation. So I'm going to subtract 2 cosine x from both sides, and when I do that, I'll have 2 cosine x is equal to 1. I'm probably going to leave it like that because it's not quadratic, so it's not going to do me any good to set it equal to 0. Here I'm going to divide both sides by 2, and now I get the cosine of x is equal to 1/2. Well, this is over the interval of 0 to 2 pi, so I want all the places on the unit circle, and my cosine is equal to positive 1/2, and that's going to be pi over 3 and 5 pi over 3. Remember, because it has the interval from 0 to 2 pi, I just leave it like that. No need to add multiples of pi. The next one, I have secant squared x is equal to 4, so I'm going to divide both sides by 3, and I'll have secant squared x is equal to 4/3. I'm going to solve that, so I'm going to take the square root. So I take the square root of everything. So I'm going to have secant of x. When I take the square root, I'm going to write plus or minus. The square root of 4 is 2. The square root of 3 is, I'm going to leave as the square root of 3. I don't know secant off the unit circle as well as I know sine and cosine, so I'm going to flip this to cosine, so that's the reciprocal. If I flip this, then I'm going to flip this fraction, make this the square root of 3 over 2. So then I'm asking myself, when is a cosine equal to a positive or a negative square root of 3 over 2? And that's going to be everything with a denominator of 6. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Moving on to the next one, it says verify the identity. So here I'm going to use the sum and difference formula. So if you remember for cosine, that's cosine x. Well, I should probably write the identity first. So let's write the identity. So like you learned cosine of u plus v, and that's going to be cosine u cosine v minus sine u sine v. That is the sum formula on your identity sheet. And so now what I'm going to do is I'm going to think of this as being my u and this as being my v and substitute in. So I'm going to have the cosine of x times the cosine of pi over 2 minus the sine of x sine of pi over 2, and I'm trying to show that that's equal to a negative sine x. So here, cosine of x I can't do anything with, so I'm just going to write cosine of x. The cosine of pi over 2 is 0, minus the sine of x, and then the sine of pi over 2 is 1. This will equal 0. Anything times 0 will equal 0, so I'm going to be left with negative sine x is equal to negative sine x. So I verified my identity. The next one, I have 8 cosine squared x minus 4 is equal to 4 cosine 2x. Well, this is the identity. The identity is actually 2 cosine squared x minus 1. So in order to get this, I would have to take 4 times that. So I'm going to write this as 4 times 2 cosine squared x minus 1 is equal to 4 cosine 2x. And then this becomes 4, that 4 there, and then this is cosine of 2x. So I've shown the left side to look like the right side. Okay, the next one says find the angle in radians. So this is where you're going to use that formula. S is equal to theta times r. Remember, this is your angle, and it has to be in radians. This stands for your arc length, and this stands for your radius. So when I look here, I see that I have a radius of 15. I have an arc length of 77. So I'm going to say 77 is equal to theta times 15. Solving for theta, I'm going to divide both sides by 15. So I'm going to say theta is equal to 77 over 15. And my units on this will be radians. Do not put a pi in there. There's no pi. No need to go get a pi. 14, a plane is 125 miles south and 45 miles west of an airport. The pilot wants to fly directly to the airport. What bearing should be taken? Round your answer to the nearest degree. So here's my airport. The plane is 125 miles south and 45 miles west. And I know the distance the plane is from the airport. Since I'm going directly south and directly west, this can be a right angle. I want to find the bearing, so I want to find this angle up here. Oh, I take that back. Here's my plane. I want to fly this, so I want this angle here. Yeah, should read the problem. All right, so I want this angle here because I want the plane to fly to the airport. The airport's not going to fly to the plane. All right, so I'm going to look for that angle. So I have the opposite and adjacent. So I'm going to first start by saying the tangent theta is equal to the opposite over the adjacent. In order to solve this, I am going to have to, since I'm looking for an angle, I'm going to have to do the inverse. So I'm going to say inverse tangent of 125 over 45 is equal to theta. When I do that, I get, in degrees, I get 70.2 degrees. So So when I draw this, I just brought this over here. This is my 70.2 degrees from my unit circle. But remember, bearing starts with this is 0 degrees, this is 90 degrees, 180, 270. And I want bearing, so I want this angle right here. So the angle that's formed here, obviously this isn't going to be drawn to scale. So to find that angle, I'm going to take 90 minus the 70.2. And when I do that, I get 19.8 degrees. And that is my bearing, the 19.8. Moving on to the next one. If the cosecant is equal to 4 times the square root of 3 over 3 and the cosine is negative, then find all 6 trig functions using any method used this year. So first of all, if my cosecant is 4 times the square root of 3 over 3, then I know my sine is going to be the reciprocal of that. So I'm going to take 3 over 4 times the square root of 3, rationalize, and I'm going to have 3 times the square root of 3 over 4 times 3. The 3's simplify, and so my sine is going to be the square root of 3 over 4. If the cosecant's positive, the sine is going to be positive. Next thing I'm going to do is I am going to probably draw a triangle. And if I draw a triangle, I know my sine is positive, my cosine is negative, which puts me in the second quadrant. If I'm looking at this, my sine is the square root of 3 over 4, so opposite over hypotenuse. I am going to do the square root of 3 squared plus b squared is equal to 4 squared. And when I do all that, I get b squared is equal to 13. So b is equal to plus or minus the square root of 13. So this is going to be a negative square root of 13 because it is in the second quadrant. So that's going to make my cosine a negative square root of 13 over 4. The secant will equal the reciprocal of that, so 4 over the square root of 13, that's negative. Have to rationalize, so negative 4 times the square root of 13 over 13. The tangent, if I'm looking at my triangle, I'm going to do opposite over adjacent. So that's going to be the square root of 3 over a negative square root of 13. So that whole answer is going to be negative. When I rationalize square root of 3, that's going to end up being a negative square root of 13, negative square root of 39 over 13. Then the cotangent is going to be the reciprocal of that. So I did negative square root of 13 over the square root of 3, rationalized by multiplying by the square root of 3. And I am going to get a negative square root of 39 over 3. Boy, that's really messy, and I really apologize. So let's just highlight those answers. So here, here. Okay, now I feel better. All right, moving on to the next one. The next one says use the half angle formula. As soon as it tells me to use the half angle formula, I'm going to take this 165 and I'm going to double it. I'm going to get 330. So that 165, I'm thinking of the cosine of 165 degrees is the same thing as the cosine of 330 degrees over 2, because the 330 divided by 2 will give me that 165. So when I go to use the formula, I want the cosine. So that's going to equal plus or minus the square root of 1 plus the cosine of 330 degrees all over 2. Well, let's do two things at once. So the cosine of 165 is in the second quadrant, which is going to make this answer negative. And then the cosine of a square root of 330 is the square root of 3 over 3. So we are going to have the square root of 1 plus the square root of 3 over 2 all over 2. To simplify this, I'm going to make this 1 the common denominator with this 2. So I'm going to think of that as 2 over 2. So now I'm going to have a negative square root of 2 plus the square root of 3 all over 2. And then this 2 over 1 I'm going to think of as 1/2 multiplied by 1/2. So I am going to end up with a negative square root of 2 plus the square root of 3 all over 4. And you can leave it like that, or if you want to be an overachiever, nothing wrong with that. I do square root, and I can have negative square root of 2 plus the square root of 3 all over 2. Either one of these answers is fine. Moving on to the next one. Remember, it does have to be negative because 165 is negative. The next one says given that A is equal to 9, B is equal to 10, C is equal to 13, use the law of cosines to solve the triangle for the value of A, which is this angle here, A. Find the area of the triangle, round your answer to 2 decimal places. So we're doing 2 for 1 here. First of all, let's do the area because that's the easiest one. So we're going to do the area. So to find the area, I'm going to do Heron's formula. So I'm going to find my S and add all my sides together and divide by 2. And when I do that, I get 16. Then to find the area, I'm going to say it's equal to the square root of 16 times 16 minus 9, 16 minus 10, 16 minus 13. And when I do all that, I end up with an area of 44.9 square units. Now to find angle A, I'm going to use the law of cosines, so I am going to say I'm going to have to use this side 9 opposite, so 9 squared is equal to 10 squared plus 13 squared minus 2 times 10 times 13 times the cosine of A degrees. And I'm either going to put that in my calculator and do and solve, or I'm going to solve it. And when I do, if I solve it, I have the cosine of A degrees is equal to 9 squared minus 10 squared minus 13 squared all over 2 times 10 times 13, and that is negative. And I end up with A being 43.7 degrees. And this particular problem only asks you to find A. Make sure when you take the exam you only solve for what we asked for. Don't try and do more than you have to. All right, well, this is a review. I hope this helps, and we will see you next time in class.